Hey guys, this is Coach Brian. I'm going over part 1 of the 1.4 notes. 1.4 is all about odd and even functions, piecewise functions, and step functions, just different types of unique cases. And this video specifically is going to talk about odd and even functions. So we're going to talk about the nature of the functions and how the leading coefficient affects the graphs. We're also going to learn to sketch them. So first thing we want to look at in a function is the largest exponent, and we determine the degree of the function by the largest exponent. So for instance, this one has a exponent of 3, so it's a degree 3. And just to clear up some terminology, a coefficient is the number, in front of a variable. Operator is just going to be the sign telling us what we do. And then constants are numbers that don't have any variables attached. In this case right here of this polynomial, we have a leading coefficient of 4 and a degree of 3. Okay, a leading coefficient of 4 and a degree of 3. So introducing even functions, all right, even functions always have an even degree. It doesn't mean that every function with an even degree is an even function, but that is kind of the first clue we're going to look at is when we look at, for instance, this one has a highest exponent of 2. This one has a highest exponent of 4. This one has a highest exponent of 6. So they all have an even degree, and they are symmetrical about the y-axis, and their degree is an even number. So what that means is if I folded this graph down the y-axis, all right, if I folded it in half down the y-axis, I would get a mirrored image. And it's going to be right down, not necessarily the y-axis, but through a vertical line of symmetry. That's a better way to put it. So if the graph is on the y-axis, such as this first example, you could fold it down the y-axis. But if it has an axis of symmetry that's a slightly offset, if you can still vertically fold it down a line and it's symmetrical, that would still qualify and be okay. So a question here says, what do you notice about the direction of the left and right ends? So if you're given a brand new graph to check out and you just go check out the end behavior, what is the graph doing at its ends? You can see that these are, for the left and the right, both ends go in the same direction. Both point in the same direction. So that's a key we want to look for. We want to, you can pretty visually, easily tell if they're symmetrical. Sometimes it's not so easy, but for these 3 examples, I could fold this in half down this line. I could fold this one in half. I could fold this one in half, and they would be perfectly mirror images of each other. Another thing we want to look at is the end behavior. So if these both point in the same directions, that leads us into our odd functions. And if I were going to look at their end behavior, you can tell one is going up and to the right, one's going down and to the left, one's going up and to the left, one's going down and to the right, up left, down right. So the thing that we notice here is that the ends are going in opposite directions. The ends are going in opposite directions. So for an even function with an even degree, they were going in the same direction. For an odd function with an odd degree, they're going in opposite directions. So that's kind of a key clue right there. And then the next question says, what do you notice about graphs with a positive leading coefficient versus a negative? So if we look, this one has, technically a positive 1 out front. This one has a -1 out front. This one has a -1 out front. So one thing that you can kind of generally see is that the positive coefficient is going to generally take my graph in a positive direction, where the negative leading coefficient is generally going to take my graph in a negative direction. So we could say positive is up on the right, or up and to the right, and we could say negative is down on the right side. Down on the right side, up on the right side, down on the right side. And going back up to the top here, I didn't really ask that question, but you can see here negative and positive. That's going to determine if my graph opens up or down. Now it says circle the answers below. Are the functions even or odd? Is the leading coefficient positive or negative? So the first thing we want to look at to determine if it's even or odd is we want to look at the end behavior. So this one goes down, up. This one's down, down. This one's up, then down. And this one's up, up. So like we said earlier, on even graphs, the end behavior causes them to go in the same direction. So our two evens are the two graphs that go in the same direction, leaving our two odds as the ones that are going in opposite directions. And then lastly, the coefficient tells us if it opens up or down, or if it goes up and to the right or down to the right. So looking at this first one, generally this graph goes up and to the right, so it has a positive coefficient. This graph goes downward or opens downward, so that lets me know I have a negative coefficient. This one goes down and to the left, so this is generally a negative leading coefficient, and this one opens up, which would be a positive leading coefficient. That is all for part 1. Also look out for part 2 and part 3, and I hope those are helpful for you going forward. Just give you a preview real quick. Part 2 will cover piecewise and step functions. Part 3 will cover step functions specifically. So make sure you look for those next. They also will be posted.